Hello, this is Ms. DB, and today we are going to talk about Chapter 4, Section 5 on scatter plots and trend lines. Our objectives are to create and interpret scatter plots and also to use trend lines to make predictions about that data. So far we've been looking at the relationships between ordered pairs, which can also represent data, and if we display that data visually, we can see relationships between that. A scatter plot is a great way to do that. That is a graph with points plotted to show a possible relationship between two sets of data, between the independent and the dependent variables. Here's an example. If we are going to graph a scatter plot from given data, here is a table with the data in it. It's the number of cookies in a jar from the time since they were baked. So this is the number of days. So on day 1, there was 24 cookies. On day 2, there was 16. On day 3, there was 10. On day 4, there was only 7. So we are going to use that data as ordered pairs, with the x, or the independent variables, being in the top row, and the y, or the dependent variables, being in the second row. So you need to make a coordinate system with an x and y axis, except that we're going to call our x-axis days, and we're going to call our y-axis cookies. So along the x-axis, we'll put the number of days, 1, 2, 3, 4. You'll see they also have options for half days. And along the y-axis, or the cookies axis, they decided to go up every 3 units in order to make it fit on their paper. Otherwise, to go all the way up to 24 would take up a lot of space. And then we just put the points on there. So at one day there was 24, so you go over 1 on the x-axis, the days, and go up to 24 and you put a point. And then for the next one, it's over 2 and up 16. You have to kind of estimate a little bit above the 15. For day 3, it's at 10, again, just a little bit above the 9 on the vertical axis. And at day 4, we're at 7. Again, a bit of an estimate there. That's a scatter plot. That's all there is to a scatter plot. Label the independent axis, the horizontal axis, and label the dependent, or the vertical axis, and give it a nice title like cookies in the jar. A correlation describes a relationship between two data sets. So a graph may show how the two different kinds of data are related. The correlation can help you analyze trends and make predictions. There's 3 types that we're going to be looking at. There's a positive correlation. That means as the x values, or the independent values, increase, so do the y values, or the dependent variables. There's a negative correlation. That means as the independent, or x values, increase, the y values decrease. So as one is increasing, the other one is decreasing. So you'll see that it's going downhill. This one's going uphill. There's a possibility that there's no correlation at all, that there's no relationship between these data sets, that there's no link between them. That's possible as well. And then the dots would just be kind of all scattered all over, and you couldn't really find a pattern. So some of your problems on your worksheet, you're just going to be asked to describe the correlation. Sometimes that will be with a graph, and sometimes it will just be with a situation. In this example, we have a graph, and you can see that as the average daily temperature, the horizontal values, increase, so do the number of visitors to the beach. So this would be a positive correlation. As one increases, the other does as well. So it's showing kind of an uphill pattern. Here's another example. This is a snowboarding competition, and the years along the x-axis show that as the years increase, so do the participants in this competition. So that is also a positive correlation. It's not as steep as our last one, but there is a trend upwards. Okay, then some of these are just going to be a situation, or an event that's going on, and you have to decide if it shows positive, negative, or no correlation. All right, so we have the average temperature in a city and the number of speeding tickets given in the city. So let's see, as the temperature increases, like 50 degrees, 60 degrees, 70 degrees, would the number of speeding tickets also increase from like 100 to 200 to 300? Or would it decrease? As it got hotter, would the speeding tickets decrease? Or do you think there's no correlation? Probably no correlation. I wouldn't think that the temperature has anything to do with the number of speeding tickets. All right, how about the number of people in an audience and the ticket sales? Now that's got a correlation. How about the more people in the audience, the more tickets were sold? Or the more tickets that were sold, the more people they will be in the audience. That's probably the way it went. So that's a positive correlation. How about the runner's time and the distance to the finish line? The longer you run, the less you have left to go, right? If you have to run a mile and you've run for 3 minutes, then you have less time than if you hadn't started yet. So this would be a negative correlation. As your time increases, the amount of time you've run increases, then the distance to the finish line decreases. Hopefully you're making forward progress and there's going to be less distance to the finish line the longer you run. In this example, you're going to be looking for matching here. You're going to match the situation with the best graph. All right, so let's see. It's the number of minutes since a pie has been taken out of the oven and the temperature of the pie. So time is along the horizontal axis. So we have the time increasing, and then the temperature is along the vertical axis. So in graph A, what do we have in graph A? Graph A shows that the pie is cooling pretty steadily. It started out at like 260, 280, and now it's dropping in temperature as the time increases. So after 30 minutes, the pie is 80 degrees, which is getting close to room temperature at that point. In graph B, the pie started cooling off at like 15 minutes before they took it out of the oven. I guess this is possible if you turn the oven off and leave the pie in there, but the situation says a pie has been taken out of the oven, so this doesn't really work then. The pie's not out of the oven if it's negative 10 minutes before it was taken out of the oven. Graph C shows that after you took the pie out of the oven, it warmed up. So there's something wrong with your house or your oven if this is the case. So the best answer here would have been A, because A shows the pie cooling off gradually after you took it out of the oven. You can graph a function on a scatter plot, a line, a straight line, called a trend line, so you can make predictions and you can see the relationship between the data better. You can even write an equation of that line. But for this lesson, we're just going to draw the line. Here's an example. We have a money collected at a concession stand and the total number of tickets sold at a movie theater. Based on this relationship, predict how much money will be collected at the concession stand when 150 tickets will be sold. So it might make sense to you that the more tickets you sell to a movie, the more money they'll make at their concession stand. That's what they're checking out. And they've graphed all of the points. They're not showing us the data, but they put the points on there for us, and then they added a line, that trend line. That trend line's a little high, but your line is supposed to go through the points. It doesn't have to go through all of the points because then it would be all zigzaggy. So it's just going to be one straight line. Some points can be above, some points can be below. It should show the general direction of the points. And once you draw your trend line, you can make predictions. You can say, well, let's see, when 150 tickets are sold, which is about right here, then how much will be sold at the concession stand? So you go over to 150 on the horizontal axis, then you go all the way up, and then you go, when you hit the line, you go straight across to the left, and that number right here is the answer to your question, which is about $750. So the estimate, the prediction is that if you sell 150 tickets, you will make about $750 at the concession stand. Here's another example. They've already graphed the data and drawn their trend line. And the question is, how many wrapping paper rolls need to be sold, that's what they're selling, to raise $500? So this time, find 500 along here. It's about right here. Then go over till you hit the line. Then go down. This number right here would be how many rolls you would need to sell in order to raise $500. And halfway between 50 and 100 is 75. All right, now we're going to look at the worksheet because there's some questions on there where you have to make your scatter plot or draw your trend line, and I want to show you how to do that. All right, so here is your worksheet. Your worksheet has some information reminding you about the different kinds of correlation, and you're asked to identify whether you'll see positive, negative, or no correlation between some pairs of data sets. Those are pretty basic. And then there is a matching. You have to choose the scatter plot that best represents the described relationship. Let's look at number 6. The price of a new car and the number of hours in a day. Well, that one's kind of silly. Let's do the next one. A person's age and the amount of broccoli he eats. This might be as he gets older, the more broccoli he eats. Number 8, this one's more clear. The number of cats in a barn and the number of mice in that barn. The more cats you have in a barn, the fewer mice. This would be a negative correlation. Graph 1 would definitely go best with that one. Number 5, the distance a person runs and how physically tired that person is. That would probably be graph 3. You get more tired the longer you run. These middle two, though, the price of a new car and the number of hours in a day. Oh, I get this one. There's always 24 hours in a day. So as the price of a car increases, it doesn't matter. There's always 24 hours in a day. That stays constant. And the broccoli and the person's age, that must be the no correlation one. All right, anyway, you can answer the letter of the graph down here. All right, so here's the part I really wanted to show you, is you are going to be making your own scatter plot for this problem. The year, it's already marked on here, is going to go along the horizontal axis, and the percent of 18 to 24-year-olds is going to go along the vertical axis. The problem is that how do you put points on here? So what we're going to do is go to, let me see if I can show you the whole top bar here in Word. Yes, okay, so insert. Why doesn't it let me insert my, I have to click somewhere else. Insert shapes, and now I'm going to pick, I'm just going to pick a circle. And I'm just going to put a point. See, that I put it in the wrong spot. But I just went to insert, shapes. Now again, it's not letting me. Insert shapes, and then pick like a circle. You can get to basic shapes from here. And then you're going to go over here and you're going to put dots at the right places. So the first one is supposed to be 1988. So here's 1988 and up to 36. So 36 would be about right here. I'm going to make my graph bigger because it's so tiny that I can barely see it. Okay. And you're welcome to do that as well on your worksheet if you want. Okay, so my first point was supposed to be at 1988 and 36. Let's see if that looks about right. It's a little bit farther to the right than it's supposed to be, but I am not going to get too picky about that. It's hard to get them exactly where you want them. That's good enough. Okay, my next point was at 1992 and 43, so this was too high. 1992 and 43 is going to be about right here. Yeah, that's close enough. It might be a little low. Insert shape. Get another one. I need one at 1996 and 32. So that's just above the 30. Just draw a little circle. And it's okay if these aren't exactly all the same size. And then I'm going to grab another one. And you could use a star shape if you want, but I'm just trying to make a circle. This is 2032. Oh, that's the same spot. And also note that mine are filled in. That's just because at some point I clicked that I wanted them to have a fill. But if yours are just open circles, that's totally fine. And at 2004, I need 42. So up to 42, about here. Whoa. That might be a little high. Just use your best guess at how to, don't spend a ton of time trying to fix this. Okay, so I've got my scatter plot done. Next, I'm supposed to draw a trend line on the graph. So as you might guess, go back to Insert. If it doesn't work, then click somewhere else and go to Insert, Shapes, and pick a straight line. All right, now your trend line does not have to start at 0, 0. In fact, in this one, that doesn't make any sense. So my trend line, I'm going to start it up here. And I'm going to go, oops, Insert, Shapes, Trend Line, or Line. I'm going to start about here. And then my line, I need some above and some below. And it should show the general direction that your points are going. I think that's pretty good. Now yours might be a little bit steeper or shallower, or maybe you started a little bit lower. But the general direction of your trend line should show some dots above, some dots below, and should show that this is increasing very gradually. This is not a drastic increase by any means. And then the next question says, use your trend line to estimate what % of 18 to 24-year-olds voted in 2008. Well, 2008 would be right here. So if I go up to 2008, that'd be about here, and then I follow that straight line across to about here, that looks like about 47, 48, somewhere in that range. Now, if your trend line was shallower, if your trend line, let me see if I can move it a little bit. Maybe your trend line was more like this. Maybe you got to answer more like 42 or 43%. So it kind of depends on your trend line and how you drew it, what your answer for C is. Now, there are statistical methods to find the exact, it's called a regression line or line of best fit, and you will look at those methods a little bit later this year and also in Algebra 2 and in statistics. All right, moving on. Here's another problem, number 12. So in this one, first you're going to make a scatter plot the same way that we talked about. And again, if you want to make this bigger, you can, just so it's easier to put your dots on it. And then you're going to draw a trend line, describe the correlation. I didn't ask you to describe this correlation, but it would be positive, but only slightly positive. And then you are going to make a prediction based on the amount of time it'll take Neil to assemble 12 sandwiches. So again, to add your points, remember, I'll just add the first one. Go to Insert, Shapes, and then pick a shape. Let's say I didn't want to do a circle anymore. Maybe I want it to be a little bit more interesting. Maybe I want this little shape. And my first point is at 1 sandwich in 3 minutes. So I go over to 1 and I go up to 3, and I'm going to add that shape. Did it add? It's tiny, but it's there. And then I would add a point for 2 sandwiches, 4 minutes, and so on. And then you'll add your trend line using the straight line and then answer some questions. If you're finding working in Word is too glitchy and you don't like this, you might want to draw these scatter plots by hand and just attach a digital picture. You can do that as well. Take a picture with your phone and paste it in here. Email it to yourself, and then you can copy and paste it, right after the problem if you want. That might be easier for some of you. All right, that's about it. I think you can figure out the rest of them. Make sure you do number 13. I've gotten some great answers for this question. You get to make up your own real-world situation that could match this graph. So be as creative as you want. All right, thanks a lot and have a great day. Let me know if you have any questions.